In this video, I want to provide an example of how the conditional independence assumption can allow us to derive some sort of average causal effect, or technically the average causal effect conditional on something. And I'm going to continue with our salesman example. So here, just to remind you, a individual person in a particular workforce makes a decision as to whether they receive on-the-job training or not. And a manager is interested in, if an individual does receive on-the-job training, what is the effect that that has on sales, or what is the causal effect which that has on sales? And what we did before is we defined an individual's potential level of sales. And we said that an individual's potential level of sales was equal to S1I if that individual chose to receive on-the-job training, so if JI was equal to 1. And for that same individual, there is a potential level of sales had that individual not chosen to receive on-the-job training. So these are two sort of innate things for each individual, and they're independent of the choice as to whether the individual did actually or did not receive on-the-job training. And what we said here was that if we compared the difference of the average level of sales between those individuals who did receive on-the-job training and those that did not, that the average would be composed of two separate effects. One, which is the effect we're interested in, the average causal effect, which we suppose is greater than 0, and the selection bias effect, which we also thought was greater than 0. We thought it was greater than 0 because we expected that those individuals who are possibly better salesmen might be the ones that are more interested in their career, and hence those might be the people that would have done better anyway. So there's definitely a selection bias effect which is acting here. However, we spoke about how in the circumstance when JI is randomly assigned, that implied then that the selection bias effect was equal to 0. And hence, just by comparing the means of the two groups in terms of the mean level of sales, that would then provide us with an estimation of the average causal effect. In this video, I want to talk about how we can proceed in the circumstances when we cannot assume that JI is randomly assigned. But what we can assume is that S1I and S0I are conditionally independent of JI, perhaps conditioned on an individual's past level of performance. So I'm going to write that as PP. So conditional on past performance, we can assume that S1I and S0I are independent of JI. But what does this actually mean? Well, we can think about the decision as to whether an individual chooses to receive on-the-job training or not as being composed of two separate components. There is the component which is due to sort of past level of sales. So this is certainly a non-randomly selected component. And just so you understand here, I'm using this whole bar to represent the variance of JI. But perhaps there is a part of JI which is random. And this is the sort of residual part of the variance of JI. So this is the randomly selected part of JI. And perhaps once we remove that non-randomly selected part of JI, which is due to past performance, then what we'll be left with is a purely randomly selected part of JI, and that will then allow us to evaluate some sort of average causal effect. Okay, so to see this, what we're going to do is we're going to just jump straight ahead and look at the selection bias term. We know that the selection bias term in this circumstance, when we're conditioning on past performance, is equal to the expectation of S0I given that JI is equal to 1, and also given that individual's level of past performance. And we're taking away from that the expectation of S0I given that JI is equal to 0 and given that individual's past level of performance. And now what we do is we actually use our assumption that S1I and S0I are independent of JI if we're conditioning on PI. And what that means is that S0I is completely independent of the value of JI. So I can just change the second value of JI to be equal to 1, and that's still valid. And in this circumstance, I hope you can see that both of these expressions are exactly the same, hence the selection bias is equal to 0. And then if you were to look at the difference in means when you actually condition on past performance, and I'm going to explain exactly what I mean by conditioning on past performance and looking at the difference in means. That then evaluates to the average causal effect conditional on past performance. And as I say, I'm going to explain exactly what I mean in future videos by the difference in means conditioning on past levels of performance, or condition on some other variable at least. So just to summarise, we can see here that taking the conditional independence assumption has allowed us to at least conditionally evaluate some sort of causal effect. And it did that by allowing us to conditionally make the selection bias equal to 0.